In this first problem, we're trying to convert between grams of iron and moles. There's a bit of language at the start that's not important to solving the question, but it's potentially interesting. For now, we can ignore it. We know that we're going to go between mass and moles, so we're going to need a formula weight. In this case, the chemical of interest is an element. So we're going to find the atomic weight rather than the formula weight of iron from the periodic table. And we find that it's 55.85 grams per mole. Now from this identity, we're going to write two conversion factors. We can write 55.85 grams is equivalent to a mole of iron, and a mole of iron is equivalent to 55.85 grams. To figure out which conversion factor we need, we go back to the statement of the question. We write down our number with its unit, 42 grams, and we know we want to get to moles. So we need to use the version of the conversion factor that has grams in the denominator so that they cancel out. That means in this problem, we're going to divide by 55.85 rather than multiplying by 55.85. Make your units work for you. All right, so if we set up this problem, we see grams divided by grams cancels out. We do our division, and our calculator answer is 0.752014. And the unit is moles, because that's the unit that survives. Now we need to go back and worry about our significant figures. So we look at all the numbers that go into our answer. This first number has 2 Sig Figs. There's 2 digits, each 1 to 9, so they both count. This number has 4 Sig Figs. Since this is a multiplication, we're going to count the number of Sig Figs. So our answer is correctly expressed with 2 Sig Figs. We look at the first number to be dropped. The first number to be dropped is less than 5, so we round down, meaning we get rid of all those numbers. So our final answer is 0.75 moles of iron. Now this next problem, we're also going to be converting between moles and mass. So we're going to need the formula weight. In this case, our compound is vitamin C, and it has that formula, and they don't give us the value for formula weight of vitamin C, so we need to calculate it. We calculate the formula weight the same way we've been doing it. We add up the mass of each atom involved in one unit. So from carbon, we have 12 atoms, each weighing 12.01. And hydrogen, and finally oxygen. So we see our formula weight is 176.14 grams per mole. We have our formula weight, so we can use that as a conversion factor to get to our final answer. Again, we can write both versions. Prior to figuring out which one we need to use. All right, so let's do our problem. We want to initial number with units is 1.42 times 10 to the minus 4 moles of vitamin C. We want to use the value of the conversion factor that has moles in the denominator, so they cancel out. That means that we're going to end up multiplying by 176.14 grams per mole. Again, we see the units of moles cancel out. If you're having issues using your calculator with scientific notation, see me or a TA to get that straightened out. Once we do this calculation, we multiply these two numbers together. We see it's 0.02501188 is our calculator answer. And we want to look at our Sig Figs. As usual, we don't round until we get to the end of the problem. Now we can worry about our Sig Figs. We see there's 3 Sig Figs that are involved in this first number. All the digits in the coefficient of a number in scientific notation count as significant. And this number has 5 Sig Figs. This is multiplication, so we count Sig Figs. We report our answer with the same number of Sig Figs as our worst measurement. This problem, our worst measurement has 3 Sig Figs, so we write our answer with 3 Sig Figs. To count the Sig Figs, we start with a 2 because these leading zeros do not count as significant. So we start counting 1, 2, 3, and we need to stop after that 0. The first number we drop is 1, which means we round down. That 1 is less than 5, so we drop all of those digits. Our final answer is therefore 0.0250 grams. Some more practice problems going between mass and moles. The next problem involves nitrogen dioxide, so we need to determine the formula weight for nitrogen dioxide. Do that the same way we've been doing it. We have a nitrogen. We have 2 oxygens. So the formula weight of our nitrogen dioxide is 46.01 grams per mole. With that formula weight as a conversion factor, or an identity, we can write 2 conversion factors. 46.01 grams is equivalent to a mole, and a mole is equivalent to 46.01 grams. All right, going back to the statement of the question, we see that we have 1.77 moles to start with. Write down the number that you're given with the unit. That allows us to determine that we need to use a conversion factor with moles in the denominator. So every mole of NO2 is going to be equivalent to 46.01 grams of NO2. So this indicates multiplication. We do the multiplication. Our calculator answer is 81.4377 grams. Now we can worry about Sig Figs. This number has 3 Sig Figs. This has 4. So we can only write our answer. We can only justify 3 Sig Figs. That's the one with the least number of Sig Figs. The first number we drop is 3, so we drop everything. So we have 81.4, and the unit that survives is grams. So we can check to make sure we've set this up right, to make sure the units that we don't want cancel out. Grams is the only unit that survives. Okay, so we're done. The next problem involves rubbing alcohol, and we're given the formulas, so we can do the formula weight. So the formula weight of rubbing alcohol comes out to be 60.11 grams per mole. We go back to the number with its unit that we're given. So we have 0.84 moles. And again, we look at the possible conversion factors that we can use. We have 60.11 grams is equivalent to a mole. And we also have a mole is equivalent to 60.11 grams. In this case, we want to cancel out units of moles. So we choose the conversion factor with moles in the denominator. So we know a mole is equivalent to 60.11 grams. This tells us we need to multiply 0.84 times 60.11. Our calculator answer is 50.4924. Units are grams. Now let's do Sig Figs. This is 2 Sig Figs. Remember, this leading 0 does not count as significant. This captive 0 is significant, so we have 4 Sig Figs. The least number of Sig Figs are the numbers that go into our result has 2, so we can only use 2 Sig Figs. Our final answer is 50 grams. We can write it 2 different ways. We can write it as 50 decimal point. That decimal point tells us that the 0 is understood to be significant, or we could write this in scientific notation.